Hello everyone. Today, I want to take you on a journey deep into the strange, mind-bending world of quantum physics, where reality itself might not be what it seems, and where the idea of quantum immortality could change the way you think about life and death. When we talk about quantum mechanics, most of us imagine a dry, abstract theory that describes fundamental particles so tiny that the naked eye could never see them. But the truth is far greater. Quantum mechanics is an entire universe where events unfold completely at random, utterly unpredictable, a world that challenges every notion of determinism in the cosmos. Imagine you're observing a subatomic particle. You can never fully know its state at any single moment. It could be in many places at once, or vanish entirely, only to reappear as if it never left. The famous Schrödinger's cat experiment shows that when the box is sealed, the cat inside is both alive and dead. A superposition like a particle with both spin up and spin down. Only when we observe it does it choose a single state. But are we truly the ones making that choice? Or is it the particles themselves that decide their own fate? The brilliant physicist Richard Feynman once said, "No one really understands quantum mechanics. When you start learning about it, you've entered a world of uncertainty, a world where nothing is impossible, yet nothing is certain, not even death. And that is quantum immortality, a wild yet mesmerizing idea that in some branch of the universe, you never truly die." A single particle can behave both as a wave and as a particle, and can even interfere with itself. If you deliberately place a detector at one of the slits the particle passes through, the entire experiment collapses into behaving like a simple classical mechanics setup. It will always show a single, definite state to our eyes. But when the detector is removed and particles are fired one by one through the narrow slits, they once again reveal their wave-like nature. They create an interference pattern proving that a particle can, in fact, interfere with itself. For the first time in history, a scientific experiment shattered our very understanding of the world, and even the foundations of physics itself. It raises a profound question. Is the universe truly as we see it? Because in quantum mechanics, a system always seems to choose its own state when it is observed. This question has fueled intense debates among physicists and philosophers for centuries. They have struggled to answer, what is the deeper meaning of quantum mechanics? And how does it shape the very nature of reality itself? To bring everything back to its scientific roots, Schrödinger formulated the wave equation, an equation that can describe every property of a wave, or even a particle, both under the same mathematical framework. When you solve a wave equation, you can determine the probability of the system's state. But in reality, the superposition of the wave always exists. It only becomes clear when you perform a measurement. However, that act of measurement collapses the wave function, breaking the quantum system. At that moment, the particle within that wave is forced to choose a single state to present itself to you. Nearly all scientists agree on this because it is mathematically and experimentally consistent. For us, it may seem straightforward. Schrödinger's wave equation is simply the best theoretical framework we have for defining the nature of a wave. But does reality actually work like this? Is what we see truly reality, or is it merely a display state? Something that only appears when the wave function collapses. Consider the famous Schrödinger's cat experiment. Reality is decided when we open the box, when the image of the cat hits our eyes, and then our brain processes that image before making a judgment. This leads to a deeper question. Is reality determined by consciousness? In other words, does consciousness cause the collapse of the wave function? On this matter, most physicists believe that human consciousness has nothing to do with wave function collapse. Instead, they suggest the collapse could be triggered by any kind of external interaction. For example, when a particle interacts with its environment, it might bump into another particle or interact with any random wave present in the surrounding lab environment, such as a stray photon or an artificial electromagnetic wave. But there's a flaw in this reasoning. If stray photons interact with the system, why doesn't the quantum state collapse immediately? Why does it seem to wait until we measure or observe it? In reality, no matter how perfectly a lab experiment is designed, there will always be some particles that slip in and interact with the system. When that happens, these stray particles accidentally become part of the quantum system itself. They participate in quantum effects and are maintained through superposition or entanglement. In fact, this is exactly what happens inside a quantum computer. No engineer can ever guarantee that their quantum computer is 100% isolated from the outside environment. They can only do their best to minimize interference. But inevitably, some stray photon will sneak in, becoming part of the system. This shows that quantum effects can spread, meaning that, within certain limits, a quantum system can link or extend its influence into the outside world. And in some cases, that influence could even encompass the observer themselves. Can you believe that all of us might, in fact, just be quantum systems existing within the universe? You see what I mean, right? We might be observers of some experimental quantum system, but we ourselves could also be quantum entities functioning inside a much larger system. To be fair, in everyday life, we don't feel any quantum effects. The world appears solid, real. No superpositions, no strange entanglements. But you can't possibly track every event in the world in real time. Essentially, everything you see is just a tiny fragment of reality. So, the reality you witness is only your subjective reality, not a universal platform shared by everyone. In other words, your world is your experience. It may or may not be the same as mine. Imagine a sealed box containing Schrödinger's quantum cat. Inside, the cat exists in two superimposed states at once. Now, choose two random people to participate in the experiment. They know nothing about each other. They are placed in separate rooms. Most importantly, neither of them knows what time it is. They are completely unaware of the clock. The lights go out. One by one, they enter the middle room to check the box. And you, the experimenter, have no idea when they do it. When it's over, Person A says the cat is alive. Person B says the cat is dead. Since there is no fixed timeline to say who looked first or last, the reality for each of them is entirely different. Their experiences are theirs alone. As for you, you have no idea what they actually did, so you can't conclude the cat's true state. To be sure, you decide to open the box yourself, without telling either of them. And to your surprise, the cat is alive. Now, instead of thinking one went in before the other, you start suspecting maybe one of them lied, or both did. That's how our brain works. It shapes reality according to logic. You don't need to know exactly what happened. your mind automatically seeks consistency. As Richard Feynman once said, no one really understands quantum mechanics. Your reality follows your own logic, but that doesn't mean it's the universal reality. And what if both of them were telling the truth? Would you believe the cat died and then came back to life? Of course not. It's too illogical. Your brain would never accept that outcome. Even if you saw something supernatural, your brain would try to explain it through ordinary cause and effect reasoning. Why? Because the human brain was never designed to comprehend quantum mechanics. All of this leads to a fascinating hypothesis. In 1957, Hugh Everett proposed a new explanation to make sense of quantum state collapse. Instead of assuming that quantum states collapse into a single outcome, Everett suggested that all possible outcomes actually exist, but not in the same timeline. Each outcome occurs in a different world. These worlds exist in parallel, yet never interact. Thus, no contradictions ever arise. Applying this idea to our earlier cat experiment, the conflict disappears. Each observer simply sees a separate reality in their own branch of the universe. But then comes the question, if the many worlds hypothesis is true, why can't we sense it in this world? The simple answer: the world always operates according to its own logic. Because you exist in my world along with everyone else here, we all seem to perceive the same cause and effect chain. That's because we've branched together. Once branches split, they never meet again. In any given world, cause and effect remain perfectly consistent. When Everett's hypothesis was first proposed, most people dismissed it outright. Even so, many physicists supported it, because in quantum mechanics, branching provides a remarkably coherent explanation for the states observed by an observer, even if the human brain was never designed to truly grasp it. Clearly, the imperfections in quantum experiments suggest that quantum effects can spread even encompassing the observer. This means that we too may simply be quantum objects, existing within an unimaginably vast system. Each branch is the manifestation of either a resonating wave or a collapsed wave function. If the wave function continues, the universe continues. If it collapses into a localized particle, the universe stops. When you are a wave function, you could in theory duplicate yourself through quantum superposition. You could even pass through barriers via quantum tunneling. And remember, waves never truly stop. A wave only ends when it strikes something. So, in theory, you might never die in some parallel universe. Of course, all of this has consequences. If we truly are quantum objects, then why does everything in our universe operate under cause and effect? Why does everything seem so predictable? The truth is, causality only operates while you exist. The universe only has meaning when you are here to perceive it. When you are gone, everything is empty. As argued earlier, you cannot experience two states at once, both alive and dead. Whenever something happens, say, the wave function collapses, you can only ever appear in one definite state. Like opening the box with the cat, there is always just one outcome before you. In the end, as long as you exist, the world around you is a chaotic place, yet it is still governed by laws. And those laws only truly matter when you can feel them. Earth may be vast, but your personal world is small. You have no idea what is happening elsewhere right now. You only know what you are experiencing. When you visit an unfamiliar place or meet a new person, in some way, you are pulling their world into the same branch as yours. But that merging doesn't last forever. In some branch, it could end at any time. The wave function can collapse at any moment. If you truly understand all of this, then you've accepted your own reality. You and I should feel fortunate, because our wave functions still exist, still branching out. That branching is what ensures our continued existence. As for the other parallel universes, our other copies, you and I may also exist there, may even know each other through this very video, or perhaps not at all. And if this version of yourself feels too hard, too exhausting, don't be too disappointed, because in some version out there, you might be enduring World War I too, with mushroom clouds blooming across the planet. You might even have been cut down already. Either way, parallel universes always exist. They always branch. We may never be able to sense them, but I truly hope that our parallel universes are infinite. And so, whether in this universe or another, thank you for joining me on this journey. Until we meet again in this world, or perhaps in a parallel one, take care and goodbye for now.